right, this video is for the rationalizing the denominator maze. Hey, if y'all don't need my help, you let me know. I got plenty of stuff to work on. So this is going to be, this is Unit 8. This is 8.0. We're starting at the beginning. So we've done this a little bit. We did this in between Thanksgiving and Christmas. We cannot have a radical on the bottom. So what we do is we multiply both the top and the bottom by the radical. Okay? So these two just smush together. We're going to keep this 2. And then square root of 5 times square root of 5. Square root of 5 times square root of 5 is just a 5. Now, I've kept it this way for a reason. Because we can cancel out the 2's. Square root of 5 over 5.
That's an answer choice.
That's an answer choice.
That's both of them.
No, it's not. One's
All right.
Oh, yeah.
So let's do another one that's just a square root. 9 times the square root of 2 over the square root of 20. You can have a radical on the top. It's the one on the bottom that's got to go. All right. 2 square roots. We multiply those. So 2 times 20 is 40. And then these radicals will cancel and I've got a 20. All right. Square root of 40 though. 40 is 2 times 20. 20 is 2 times 10. 10 is 2 times 5. So the square root of 40 I could rewrite. So I've got 2 2's. So that's 2 squared. And then I've got a 2 and a 5. So this and this cancel. That's why I want to break it down like that. And then 2 and a 5 combine to make a 10. That just replaces that square root of 40.
Is the 2 not under a thing?
It cancels out with that exponent of 2.
Oh, so there's not.
So would you
That's
add
why
that
we
nine?
want to pull it out. Okay, so that's being multiplied by 9. This is 9 times the square root of 40. If this is the square root of 40, I can multiply that by 9. But I'm not going to do that yet. What I'm going to do is 9 times 2 times the square root of 10. 20 is 2 times 10. The reason I wrote it that way is because I saw the 2 up here and I knew 20 was even. So I can cancel those 2's out. So I have 9 times the square root of 10 over 10.
Wait, what happened to 2? Can you explain that again?
It cancels out. So 20 is the same as 2 times 10. Factors cancel out. All right, so those are square roots. We want to look at a cube root. So we're actually going to jump to this one here, this cube root. Cube roots are a little bit different. This one, you're going to end up going through this spot, so that's why I'm jumping over here. So you got to finish the path to get to here. Okay? All right. 5 over, this is a cube root. All right. To cancel a cube root out, we are going to multiply. Now I got to think how to do this. 3, so a cube root, and then I'm going to do 25 squared underneath it. So it's the same thing except we square what's underneath it. So here's why. If I multiply these two things together, 25 times 25 times 25 is 25 cubed. I want 3 of those 25s so I can cancel that cube root out. Okay. All right. So I have 5. And then what's 25 squared? Somebody do it for me really quick.
25 squared?
Yep.
Yeah, I can't do that in my head.
Somebody do it really quick. You got a calculator in front of you.
400 or 625.
625. All right, and then we canceled this out, so I've got a 25. So now I've got to break 625 down
Wait, why do we square the 25? I'm confused again.
because you need 3 of them to cancel that cube root out. Okay, when you're multiplying cube roots, keep the cube root. 25 times 25 times 25, that's what I have there, is 25 cubed. The cube root and the cube cancel each other. Because you need 3 of them. You don't need 4 of them. You've already got 1 here, then you've got 2 here. Does that make sense? Okay. All right, so 625. Let's break that down. Oop, I kind of messed up my spot there. So let's do it here. 625. We know it's divisible by 5. And 5 is a good prime. 5 and 2 are the easiest numbers to start with when you're breaking it down. 125 is divisible by 5. And then 25 is 5 times 5. All right, so the cube root of 625, I need groups of 3. 1, 2, 3. That's the cube root of 5 cubed. And then I've still got this one left over. So the reason I want a group of 3 is so I can pull stuff out. That replaces this, not that 5. This is still being multiplied by 5. So up here, I'm going to do 5 times this 5 times this cube root of 5. And then 25, that's got a 5 in it, is 5 times 5. I'm off somewhere on that one. No, I'm not.
Can we take those 2 5s out?
Mm-hmm. This 5 cancels this 5. This 5 cancels this 5. It's just the cube root of 5. That's all that's left.
That's a lot of work.
But again, it's something you've got to do to be able to find inverses. So that's why we're practicing it.
After doing all this, I'm not supposed to be an engineer.
Oh, you should see that math. It's fun. Differentials. All right. 2 over the cube root of 4. Okay, cube root. So it's going to be the number under the cube root squared. Okay, so multiplying these together eliminates everything but the 4.
Say that again?
Multiplying the cube root of 4 times the cube root of 4 squared eliminates everything but the 4.
Okay, gotcha.
Because you've got 3 4s, so you've got an exponent of 3.
Yep.
Exponent of 3 cancels the cube root.
Okay, gotcha.
All right,
And the square, you just got rid of the square.
so 4 squared is 16. All right, so we're gonna see if we can't break that 16 down. 16 is 2 times 8. 8 is 2 times 4.
2 times
2
2.
times 2. I need groups of 3. 1, 2, 3. So the cube root of 16 is the same as the cube root of 2 cubed. 1, 2, 3. That's where I got that. And then I got a 2 left over. So it goes by itself. This cancels this. I still have this 2 on the outside though. So this is 2 times the cube root of 2. That just replaces this. So now I've got 2 times 2 times the cube root of 2. And then 4 is 2 times 2. So this cancels this. This cancels this. And that's all I'm left with. Mm-hmm.
It's not that hard. You just need to meet.
It's
It's a lot of steps.
it's a lot of steps. All right, let's do another one.
Can you go a little bit slower on
Yep.
this one?
All right. 4 over cube root of 12. So here's what I need you guys to do because I'm about to kick you out into the cold on your own. I'm going to go through each step. If you do not understand what I did or why I did in that step, I need you to stop me and I need you to ask. It does not bother me. It does not upset me. Okay. Cube root of 12. I can't have any roots on the bottom. So what I multiply it by, in this case, I need 3 12s. I've already got 1.
So you gotta do 2 more of these.
So I'm going to do 12 squared, but I still have to cube root it. So when I multiply these two things together, so let me do it this way. So when you multiply fractions, top times top. 4 times the cube root 12 squared is 144. All I did was do 12 squared
Yeah.
and just write it out. Okay. Cube root of 12 times the cube root of 12 squared is the cube root of 12 cubed. There's 12 here, and then 12 times 12, or 12 squared is 12 times 12. That's where I'm getting the 3 from.
Yeah.
Okay? All right.
Oh, isn't your bottle just off?
So this cancels this.
Now we gotta find the prime numbers of 12 or 144.
144. So here's what I'm at now. I got a 12 on the bottom. So my bottom's good, but I got to simplify the top. So 144 is what we want to do. The easiest way is to go back to what made the 144. 12 times 12 did. But 12's not prime, but it at least breaks it down into smaller chunks. So what 2 numbers can I multiply
2 times 6.
to get a 12?
3 and 4. 2 times 6.
2 either. I'm going to show you that either would work. So 2 is prime. And then what 2 numbers multiply to give me a 6? 2 and 3. And those are both prime. Even if I pick something different, if I pick 3 and 4, it would still be the same factors. 2 times 2 times 3. 2 times 2 times 3. All right, we need groups of 3. So I've got 1, 2, 3 2s. Okay. I don't have any more triplets. I could put each of these in its own cube root, but I don't want to do that. I'm going to put them in 1 and multiply them together. I'm going to have to do it anyway, so I might as well do it now.
Get rid of this 12.
Okay, so the cube root cancels the exponent of 3. 3 times 3 times 2. 18. That is just the simplification of this. Now I want to break everything down. So what can I break 4 into? What 2 numbers multiply to make a 4? All right, so I'm going to do 2 times 2 instead of that. And then instead of the cube root of 144, I'm going to write this. 2. And then 12. Well, we know what 12 breaks down into. 2 times 2 times 3.
Here, the
2 and 2.
and then give her the next one with that 3.
Nope.
No, it's just this.
It's not a factor. That's something completely different than this.
So the answer is 2 times the square or cube root of 18.
Yep. So 2 times the cube root of 18 with a 3 left over. Which is this one. So let's do one more together. All right.
5 to the cube root of 50.
5 cube root 50. All right, so what do I have to multiply by to get rid of this? Not the same thing.
You need 3 to the square root of 50. Well, not, you know.
Squared. The cube root of 50 squared.
50
Squared.
squared.
Alright, and then we're gonna do a 50 squared at the top.
Yep.
So how do we just add in the square? How is that possible?
I can multiply by anything I want to multiply by
Check them up on the top and
as long as I do it to both the top and the bottom.
Okay, gotcha.
So I'm using that because that's how I get rid of the cube root.
Yeah.
That's the ultimate goal, is to get rid of that root on the bottom of the fraction. Okay. So when I multiply these, all I'm left with is the 50.
Yep.
And then here I've got 5 times the cube root of 50 squared. So what is 50 squared? 2,500. So we're about to get big. So this is 5 times the cube root of 2,500. So y'all can see where my numbers are coming from. Okay. So we know 2,500 is 50 times 50. What can I multiply together to get a 50?
5 and 2.
What? 25 and 2? 2 is prime. All right.
5 and 5.
5 and 5. If I pick other factors, if I pick 5 and 10, 5 is prime, 2 and 5.
2 and 5.
All right, group of 3. 1, 2, 3. 3 5s. And then I've got 2, 2, and 5. 2 times 2 times 5. So this will cancel for me. 2 times 2 is 4, times 5 is 20. So, and that just replaces this. That 5 is still up there. So don't lose numbers. All right, I got 5s here to get rid of. 50 will break down into what?
5 times 2.
2 times 5, right? 5 times 2 times 5. So this 5 will cancel. This 5 will cancel. Cube root of 20 over 2. Which is,
So 1 going to the bottom left.
yep.
You don't want to do one more?
The square? Yeah, I'll do another square. So let's go back up here.
You want to do the second one to the right? On top?
Wait. So we went here. Let's do this one.
Yeah, that's
All right. 9 times the square root of 3, 5 times the square root of 8. So I'm trying to get rid of
square root.
the square root of 8. Okay. So I've got 9 times the square root of 3
Times the square root
times the square root
of 8.
of 8 back up at the top. And then here I've got 5 times square root of 8 times the square root of 8 leaves me an 8. Okay, radicals. Keep the radical. 3 times 8 is 24. Does everybody see where I pulled that 24 from? Combining those radicals. And I'm going to leave this as 5 times 8. All right, 24. Let's see if it'll break down. 2 and 12.
8 and 3.
Wait, 3 and 4. And then 2 and 2. So for squares, I just need a group of 2. 2 and 2 would be the square root of 2 squared. 3 times 2 would be the square root of 6. Square root and exponent cancel. 2 times the square root of 6. Okay, so again, that is just...
So now it's 9 times 2 times square root of 6.
Is there a 2 that I can pull out of one of these two numbers? 8 I can write as 4 times 2. This 2 and this 2 cancel, and then I smush everything back together.
So it's 9 times square root of 6. And then it's over 20.
Over 20. All right, so listen, it is really easy to start getting twisted and turned. You get twisted and turned, you stop, you take a breath, you let me help you. Okay? You have got, so do you want to know how many more arrows you need? So you need a total. Here's the total number of arrows you need colored. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. We've done 7. That means you got 8 left. So you need 15 total arrows colored. Okay, so either start here and work your way to this box. This is kind of your first checkpoint. And then from here, you've got to get to the end. Yep.